So dear students, so let's look at the artificial intelligence numerical question. So first we'll look at the blocks world problem, which is a part of the hill climbing algorithm. So uh, here this is the initial state and this is my goal state. So I have to move from the initial to goal state applying the hill climbing algorithm using this heuristics. So hx is equal to +1 if the tile x is at the correct position and hx is equal to -1 otherwise. So let's look at a solution. So what we'll do here is like uh, here if you see uh, so A, C, D, B, this is my initial state. So I will calculate. So B, now the goal state looks something like this. B, E, C, D, A. B, E, C, D, A. B, E, C, D and A at a different place. So now B is at correct place +1, E is at wrong place -1, C is at correct place +1, D is at wrong place -1 according to this goal state. This is my goal state. So accordingly I will calculate the total heuristic h is equal to -1, that is, and then I proceed to the next one by this is h equal to -1. I proceed to the next one by shifting B on top of E. So I make a random move and then I will calculate the h value. So h is coming as -3 as per the given heuristics. So this is the problem. So even if the h value is giving me -3, it is suggesting that it is not a better move. Still I have to carry out or proceed further with this move. So this is a different variant of hill climbing. So we have to follow this approach. So we have to make some random movements. Now D has to come here, then after that C can be on the top, and then we can place similarly proceeding further onwards. We'll see we place D here and then on top of that C. So we come closer to the goal state. From the initial state we will see how we can come closer to the goal state irrespective of the h value. So gradually at the end, during the end, h value will give us good h value will increase as it is pointed here. So you can see here h is +1, here h is again +1, +3, +5. It is getting better. So this is how finally we reach the goal state. So this is one application of the hill climbing algorithm in applying the blocks world. Okay, so thank you. Now there is one more problem with this, that suppose we say that to correct support structure. So this heuristic says that hx is equal to +1 if the tile x is at the correct position and -1 otherwise. But suppose we will solve this problem with a different heuristic. The heuristic is like we give it that we say that that H. So there is another part to this blocks world hill climbing problem, in which a different type of heuristic we can apply. For example, we can say here that a +1 be given for each block that is resting on the thing it is supposed to be resting on, and -1 for each block that is given if it is resting on a wrong thing. So it is called as a local heuristic. If a block is resting on the correct thing as per the goal, then +1. If a block is resting on a wrong thing as per the goal, then -1. So this is called local heuristic. Apart from this, we can apply also a global heuristic that is popularly applied, that says that a +1 for each block that has the correct support structure, +1 to every block in the support structure, and for each block that has a wrong support structure, -1 to every block in the support structure. So how do we see this? For example, this is our goal state and this is our initial state. So in the goal state, B is resting on E, C, D on the bottom, so it is given as +3 for every block, 1, 2, 3, +3. Similarly, E is resting on correct 2 blocks, so +2. C is resting on correct D block, +1. So, and above it there are 2 blocks. So in this way the points are awarded. Here B is resting on, we can say, C and D. C and D are correctly placed. C and D are below B, and A is also on the ground, so we can say +2, and D has a incorrect support structure, -1. C has got B as the correct one, and we can say that D is incorrectly placed, but B is correctly placed, and A and E are correctly placed. E is not correctly placed, but E is here neither it is neither it is correct nor incorrect, so it is 0. Similarly, A is on the ground and it is neither correct nor incorrect, so 0. C is, you can say, correctly placed as per here, +1, because it has to be on one block and it is there, so we can say +1. So total we can say H is equal to +2. Now here again B, we place it, we move a random move and we place B on top of E. So B here, it is neither correct nor incorrect, so 0, and D is -1, C is +1, A. Similarly we proceed further and we make a move, so then C also we move it to here, and C is neither correct nor incorrect, 0. So now in this way we move A to here, this side, and C we place on A. C is incorrect, -1. So in this way we proceed and we reach the goal state here, that is slowly we see that on top of D, if C is placed +1, and then on top of C is placed +2, and then top of B